Hello everyone, let's build regression model with interaction variables. So the question is, according to the WHO, the health of the individual is determined by factors: income, education, genetics, and social connections. In a survey of 120 American adults are asked how they rated their health and social connections on a scale of 1 to 100. Information is also gathered in their household income. The incomes are in thousands, and college education. If a person has a degree or has a college or a bachelor degree, the value is going to be 1, otherwise it's going to be 0. So first of all, we are going to call the data, look at the data. By the way, I forgot to say something. I'm working now on the project of chapter 8. So this is chapter 8. So I created, as we did before, either you do a new project. Let me just show you quickly. If you created already the folder, so you can use existing directory, you can choose the folder of chapter 8. If you did not create the folder of chapter 8, you can just say new directory as we did before. So these are the data that we have. We have health, social, income, and college. And you can look closely by looking at the structure and look at the values. We have numeric values, all of them. Also, it's a good idea to find the summary. If you find the summary, that means you're looking to the minimum, maximum. So you know the range of the data, which is good. So the health, the minimum we have 50, the maximum 98. Social, we have the minimum, maximum, income, minimum, maximum, and so on. And these are in thousands. So this is 21,000 multiplied by 1,000. For the college, because it's 0, 1, so we have basically two values, 0 or 1s. So we have it's a binary variable. So the first part says estimate and interpret regression model for health using social, income, and college as the predictors. Then the question says predict the health rating for the educated college or person given these values. What if the person is not college educated? So let's study this. Let's build, I would say estimate to be better, maybe word, estimate linear model. So how to do this? Again, we're going to call it linear model. You can give it any name. And we are going to use LM function. The response variable is health. Because we are going to write the health in terms of all of the other variables, it's enough to use tilde dot. This is my first argument. Second argument is going to be my data. So we have two arguments. The first one contains the formula. The second one contains my data. After that, it's a good idea to look at the summary, right? So if you run this one, what we get the estimated model. By the way, I forgot to write the estimated model in most of the recording. So what you do is let me use LaTeX. It's mathematical equation. I'm using $2, and this is the estimated model. So y hat, which is now it's health. So I'm gonna say hat \hat curly braces health. That means I'm putting health hat on the top of the health equals the intercept 34.92 plus 0.1628 social, right, plus 0.0987 income plus 19.697 college. So this is the estimated model, right? So this is the estimated model, and now we need to plug the values. So these are the weights. We just take the weights, and if you look at all of them, they are significant. All of the weights, all of the predictor variables are significant individually and collectively, because the f value is high and the p value is less than 0.05, the significance level. So we have a significance impact collectively and individually. Makes sense? After that, the question says, what does the question say? It says predict. So we have to do prediction now. So let's do prediction. Again, if you remember, we use predict as a function. We need to plug in some values into the model. So this is the model. If you remember, this is the model. We need to plug in values. The values have to be in a data frame. Social is what? What does the question say? What is the social? The social has to be 80, income has to be 100, and a person has to be a college educated. So I give you a person who's educated. The social score is 80. He has an income $100,000. Give me whether the person is healthy or no, right? Or give me the index of the health. So social is, I forgot, 80. Income is 100. And college as a variable equals 1. He's educated, right? He's educated. So let's do this. So the health score is 77.5 for a person, an educated American with a social score of 80, with an income $100,000. You can write this down, so you can use concatenate, by the way. The health rating of a college educated person given social 80 and income 100 equals, comma, let's write all. So this is the value that we have to report, right? So that's why I'm going to call it P. It's going to be easier for us. So to just type P here. Here we go. I don't like equal is. That's fine. And the question still saying that, what if a person is not college educated? So the second, we can say, let me copy the whole thing. You can just replace the college to be 0, right? So we do not want to override this one, because this is the p-value. We assign p to be the predicted for this person. We have another person has the same social scale, the social index and income, but he's not educated. So let's call it p. So let's run all of them. A non-educated. Wow, look at the education. I don't know. Look, this is something important here. Look at the other. The other sentence is just stuck next to the first one, so we have to leave a space. So what I'm going to do from the first one, I'm going to do comma /n. That means go to new line. Here we go. I mean, these data comes from trusted sources, I guess. So look at the education, how play an important role of people's happiness. Anyway, this is just one case, and this is one model, by the way. Let's go to the second model. The second question. The second question says, estimate and interpret an extended model that includes interaction of social with income and social with college. So you have to include two things here. Predict the health rating of a college-educated person given social and income. What if a person is not college educated? So we're going to do the same thing, the exact same thing, but what we're going to do is just creating an interaction model. Let's call it interaction model. Just for let me model that way. Linear model, health, let me write the formula first, health. I'm not going to use tilde dot because I'm going to add interaction terms, so I have to write all of them. So tilde only, social, tilde is like equal, social and the income, also the college. We need to add two interaction. The question is, let me say something. The question says, build this model. What if you work in your project? What you have to do? You have yourself to build these models. You have to try them. You have to try combining social with income, social with college. So, I mean, there are many techniques, advanced techniques. We can know which one works, which one doesn't work. But for now, yourself, you have to investigate. You have to explore. You have to troubleshoot. You have to do all of this. My data. You have to try different combinations and see, right? If you do interaction, I'm talking about interaction now. So this is the interaction model. So let's find the summary of that one and see what we get. We have all significance except the college. It's not a big deal. The adjusted R squared is 79. The previous one, the adjusted R squared was 78. So this one is higher. The residual error, the standard error, is 7.8. This one is 7.6. We will be discussing, or we'll be comparing the models in the third question. Let's now answer the second question. So let me just copy this so that I don't want to repeat this. So the estimated model, let me be very careful here. This estimated model, this is not correct, but we have to change first all of the values. So we have 22.816. I'm just giving an approximation here. So you have to write all the numbers. 3217, let's say. For the income, we have 2355. For the college, we have 05876. We have to add two more terms. The first one is minus 0.0018. This is social times income, plus 0.252 social times college. So we added two more terms. Look at them here. Let me just take this a little bit here. That's perfect. So So this is the expected or the estimated model we use interaction terms. Let's do prediction now. Let's do prediction. Again, I'm going to copy this, so I don't want to repeat everything, but I have to be carefully treating numbers and changing variables. So if you don't know, so first of all, I'm going to predict. This is not the linear model. We are doing the interaction model. Interaction model. I'm going to plug in values into the interaction model, and I think we're going to use the same values: 80, 100, educated and non-educated. So this is 80, this is 100 educated, and this is again interaction model for educated, non-educated. But again, I don't want to overwrite the previous P's and P's and PP, so I'm going to call this Q, this is a Q, just for the sake of simplicity, that's it, because I want to add this to the concatenate function, that's why. Let's run and see how this model does in terms of a prediction power. We got slightly higher than happiness indices compared to the previous one, if you notice, right? So, first of all, so this is the answer to the question. So the last part says, explain which of the two models is preferred for making predictions. This is important now. So let's go back and look at the adjusted R-squared. This is 79%, 0.6. This one is, again, let me just please do the following. So I don't want to go up and down. Summary L model, summary, what do you call it? The other one is interaction model. Does that make sense? Underneath each other now. Adjusted R-squared for the first model, which is linear without interaction variables, we have 0.78, we have here 0.796. Now, let's discuss the second thing, the significance of the individual coefficients. All predictors have low p-values, so they are significant here for the first model. So the second model, the college is not significance, while others are significance, right? All of them are significance except the college. The residual standard error is 7.6. This is 7.8, so the second one is lower. So considering all of the factors, we believe that the interaction, or the model 2, the interaction term, appear to be slightly doing better than the first one because it has a higher adjusted R-squared and a slightly lower residual standard error. So let me write this. Let me pause and write all of this, then get back. So we write the summary here. So we're going to go for the second, right? So before you finish, make sure that every time you do what? Let me here add a part, which is header. So there's the first header, 3 stars. This should be 4, 3, yes. This is a 3, linear model with interaction, regression. Then here we go. After that, what you have to do is net your work. This is HTML. I want to do this as a PDF. Make sure you fix the headers and they make sense and summarize all of your work. Yeah, that's it for the interaction variables. Thank you.